I'm so honored to be here and just grateful for the opportunity. And I realize that I'm the last thing between you and cocktails today, so I will try to make this exciting. I'd like to talk a little bit about the implications of artificial intelligence. It's research I've been doing for quite some time now, and I've been looking at research implications both in terms of cities and in terms of urban society and also in terms of business. And to do that, I want to go back in time a little bit and set a little context. So in the last couple of years, it seems as though we've been hearing about and talking about artificial intelligence at a fever pitch that we really haven't seen in quite some time. But if you go back, you realize that artificial intelligence is actually, this idea is about 70 years old. And it actually dates from 1950 when Alan Turing, who is the person after whom the Turing test was named, wrote a piece called Can Machines Think? And then it was a further 6 years before the term artificial intelligence was coined. And so what's interesting about this concept of artificial intelligence in the smart city is that we're really thinking about the ability of a city or any organization of people to take in data and to learn from that data and to make decisions based upon it. So over the course of the next several decades, there were these periods of tremendous explosion, and then they were followed by these periods of not very much happening, these what people call the AI winters. And today we've hit a point where artificial intelligence is actually real and possible. Now, I'm going to explain a little bit about what I mean by artificial intelligence, because one of the challenges with talking about this is that there are so many definitions floating around about it. But there are three kind of criteria that make AI real. The first is just tremendous amounts of data, what we think of as big data. And then the second is an increase in inexpensive computing power. And then the third is improvements in algorithms. And when you take all those things and you put them together, then AI becomes a real possibility. But I think it's important to talk about what we mean by AI, because a lot of times, I mean, for those of you who work in this area, you have conversations with friends or family or people that you meet, and then they start thinking about, this idea of the singularity. So when will be the point at which machines will overtake human cognition or human capability? Or they start thinking about this idea of, robots and Terminator and Blade Runner and all this kind of stuff. And so it's important to think about AI in sort of two different categories. One is this idea of general AI, so the idea of machines that can actually simulate human capabilities, but in kind of a real way. Sort of what we see a little more in science fiction, like Westworld or Blade Runner. And then this idea of weak or narrow AI, which is focused on a specific use case. Now, weak or narrow isn't a bad thing. In fact, weak or narrow AI is the kind of stuff that we're seeing on a regular basis, coming out of businesses, coming out of academic institutions and nonprofits, and actually a lot of the basis upon which we're building technologies today. But it's important to think about this because when we think about the capabilities of artificial intelligence, they really don't make sense until you put them in a specific context. So the next thing that's important to understand as you think about artificial intelligence is, what does it actually mean from a human standpoint? And one of the challenges of artificial intelligence is that nobody actually agrees upon what human intelligence means. That's a lot of the difficulty, right? So we start thinking about artificial intelligence in terms of computation or in terms of, its ability to simulate human behavior. But you really need something underlying that to give it a little bit more of a context. So in the research that I was doing, where I was asking, engineers and academics and all sorts of folks from business and elsewhere, non-government organizations, what they thought artificial intelligence was, I realized that we needed to kind of take a step back. So I went to a framework that was developed in 1983, actually, by a developmental psychologist named Howard Gardner, who's now a senior professor at Harvard. And his theory, was this theory of multiple intelligences, that every human being has these different kinds of intelligences in different quantities. So some people are very, very strong in logical and mathematical intelligence. Some people are stronger in emotional intelligence. Some people have very strong language intelligence or spatial intelligence. And so when you start thinking about that, then it starts to make a little more sense what artificial intelligence could be. The first thing we think about is this logical mathematical intelligence, because clearly computers can compute data at a rate that humans can't possibly do. But then you start thinking about some of the failings in what we see in the early prototypes, and they have to do with the ability to understand emotional signals or emotional behavior. Or they have to do with things like creativity. We wonder sort of what that might look like. So let me give you a few examples of what we're seeing in the world right now. And they hit on a few different areas. The first is visual intelligence. Now, you may have heard of this, or you may be thinking about this in terms of computer vision, which is the ability for computers to detect images and process them and analyze them and make sense of them. But here's kind of a fun example. So this is an image from Flickr that I uploaded to a site called Clarify, and you can see the logo in the upper left side. If you want to look for it, it's clarify.com. You can do this with any of your video or any of your photographs in your phone. Upload it to the clarify.com demo, and it will tell you what it thinks is in the image. Now, what's interesting about this from a business standpoint is that it actually provides the capability to do audience segmentation in some very interesting ways that we wouldn't see using language alone. Obviously, you can see the implications for things like facial recognition and surveillance and city planning and all sorts of other things. But let's kind of run down this example. So if you look at this image, everybody immediately in this room understood what this is. It's a picture of two people at a wedding. But if you look at these numbers on the side, you can see what the predicted concepts are based on this photo. Now again, there is no metadata in this photo. It is simply a photo uploaded with no other information. The first thing it thinks is with a 0.999 certainty that this is a wedding. The next, that there is a bride, with slightly less certainty that there is a groom. It's interesting, right? Here's a theory. And it's a tiny little variation, but the theory is bridal dresses are very recognizable, but men wear tuxes a lot of the time. So you don't necessarily know that, to a certainty that a man in a tux is at a wedding unless he's in the presence of a bride, which makes it more likely he's at a wedding. Then we see veil, bridal, and if I had been thinking ahead, I would have had this translated into Finnish because you can actually do that. Ceremony, marriage, and bouquet. Now, and they each go down in certainty. Now, what's interesting to know about these with these confidence levels is that when you look at these words, some of them are conceptual, i.e. bridal or wedding, and some of them actually have to do with objects like bouquet or bride or groom. And so the capabilities that we're seeing in this visual spatial intelligence or in computer vision is the ability to understand objects, a book, a person, a car, attributes, the number of people, the colors, all those sorts of things, and then other kinds of context, these kind of conceptual tags as well. So this is a pretty interesting way that we're seeing artificial intelligence develop, and you can imagine what some of the other implications might be. Then we move to auditory and linguistic intelligence, and this is the ability not only to understand written language, but to understand spoken language and to listen with intent. So if any of you have an Alexa in your home and you say, "Hey, Alexa," then of course you understand that this device is listening for that wake-up word, that wake-up phrase, and then is ready to take an instruction. Now, here are a couple things that we're seeing that are kind of interesting just from a societal point of view. So on the left side, we have a banking bot, a banking chatbot interaction. Now, in this interaction, what's important to understand, and I'll read a little bit of it to you, is that in the first instance, the bot is asking how it can help, and then the person is in blue, so that would be me, let's say. How much did I spend on Uber last month? And then it looks and says, well, you didn't really spend anything on Uber that I could find. And I say, what about Lyft? Now, the thing about this that's important to understand is that in a normal interaction with a device, if I say, what about Lyft? It will say Lyft is a company based in San Francisco that has this many people and provides ride-sharing services. In this case, it understands that what about Lyft is directly related to the question about Uber. And so now it gives me the answer and asks if I want it to break it down. So it has now held the context from the first interaction to the second interaction. And this is really important because when we think about linguistic intelligence, the idea of being able to contain content and bring it from one interaction to the next is critically important. And as human beings, we take that for granted. Now, this one on the right is about a transfer of money from one person to another. It's the same idea. I want to pay Emily $5. It recognizes that I or whoever have two friends named Emily. It asks for clarification. I just give the last name. Again, it understands. It's directly related. And then I change my mind and say, how much do I have in my checking account? And so what it's able to do here, and this is really the direction for conversational interfaces, is it says, sure, you have $2,000 in your Bank of America, blah, blah, blah. Now, where were we? Let's confirm. The reason you do this in a conversational interaction is that the person on the other end may have forgotten where they were. They may be driving. They don't have any signals the way that you have in a form on a website that you fill it out and it says, you forgot to fill in this piece of information. And so these conversational interfaces need to make sure that it is helping you through that process of getting what you need. On the right side, we have a Doctor Who bot, and this is from BBC. Apologies to any of you watching Doctor Who. This is the last Doctor Who, not the current one. And this is actually being used to try to re-engage or engage people in interactions outside their normal television viewing audience. Now, with the BBC, the average age of a BBC viewer is 60 years old, 60 years old. What's important here is that they want to engage people both of different ages, but also beyond the sort of typical viewing cycle. Now, when you think about ways of sharing information or delivering information to people, one of the things about conversational interfaces is that you can have this mix of video, of buttons, of text, and you can actually use that as a way to deliver information to people in kind of an innovative and new way. So that's being done. The next example is one that everybody's been talking about, which is, of course, motor intelligence. And this doesn't just have to do with autonomous vehicles, but it also has to do with things like drones that can fly over areas, and you've heard plenty of this today, but can fly over areas, can survey damage, and then most importantly, can collect data over time. So longitudinal data, to be able to understand patterns, because the real value in machine learning and in artificial intelligence is the potential to see patterns that we normally wouldn't see, either because we don't have access to the data, or we can't compute it fast enough, or for other reasons. And then we move into musical intelligence. And I'm not sure if this demo is going to work, so I'm going to give it a try. Maybe if you can try it from the deck. See if you can play the music that is that's on the slide. And if you can't, I'll just tell you what it is. Nope? Okay, well then I'll tell you what it was. So if you go to the back, I'll go to the past slide for a second. So this is actually, if you get a chance, it's kind of funny. It's a little song that was actually written by AI. This is a lab prototype that Sony has done. And the idea was to actually take a corpus of music, hundreds of thousands of songs, and to look for patterns, and then to say, okay, now write me a song in the style of the Beatles. And so the song that I was hoping to play is called Daddy's Car. This is, by the way, completely AI generated. And it actually sounds, to my ears, a little bit more like the Beach Boys than the Beatles. But the idea is people are working on these projects, both related to video and music and other kinds of creative efforts. And existentially, we might be asking, can it ever approach human capabilities? Personally, my philosophy is no, but there's some interesting applications. Now, the important piece here is that AI is incredibly powerful, potentially. We are at the very, very beginning of all of this. And it is also far from perfect. So all sorts of strange things happen when you start teaching machines with data. And one of the most obvious things is that machines can only learn from what you give them. They don't have morals, they don't have intentions, they don't have romance, they don't have values. They can just learn from what they've seen. And so in the case on the left, this is a story from Business Insider in the United States about the Amazon.com recommendation engine. And apparently, people were buying certain items, and when they bought a certain collection of items, people would suggest other items, which apparently could be used to create a bomb. Why this happened, I don't know. I mean, you can speculate. But some very strange things start to happen once you start to give machines the ability to learn. So we have to be really mindful. To put this in a little bit more context, this is a story on the right about Volvo's tests of driverless cars in Australia. And so what happened when Volvo introduced, not to the market, not to the public market, but just as a test project, their driverless car in Australia, was that the cars started crashing into kangaroos. And the reason the cars started crashing into kangaroos was that the engineers were all based in Sweden, where the most common animal are moose and elk and whatever, deer, those types of animals, right? And they move like this. They move like we do, more or less, on 4 legs. But kangaroos move like this. The reference point for the driverless car was the ground. That doesn't help when you're dealing with a kangaroo, because if a kangaroo is up here, the next thing you know, it's on your windshield. Now, what's important about this is that any 3-year-old can tell you that kangaroos hop, but the AI didn't know that. And the AI didn't know that because there wasn't anyone on the team who said, what about kangaroos? What about Australia? And so this starts to paint a picture of some of the things that we need to be mindful of as we are building systems using artificial intelligence, which is to say that they encode our biases. So in one case, if we have a bias for animals that move like this, because we don't have context about animals that move like this, then we will miss that signal. This is part of a study that was done by some researchers from Microsoft and from Boston University. Now, without getting too technical on you, there is a data set, a corpus of, I think, 30 million, I don't know how many words, but from a number of words taken from 30 million Google News stories. It's used to train search engines, recommendation engines, and other applications on natural language. And what they found as they started looking at this data set was that it was, in their words, blatantly sexist. And they used a kind of mathematics called vector space mathematics that looks at word embeddings, which basically means how words are connected to each other with context. You could think about that as analogies. So Paris is to France as Tokyo is to Japan. So what they started to find was occupations that were extremely male biased and occupations that were extremely female biased. So on the male side, we have maestro, skipper, protege, philosopher, captain, architect. On the female side, we have, you women in the audience will love this, homemaker, not that homemaker, there's anything wrong, I myself am a homemaker, but homemaker, nurse, receptionist, librarian, socialite, hairdresser. And so you start to understand that when you have these data sets that include the bias, our own human bias, all they can do is amplify and replicate that. So what do we do about this? There's a lot in the news right now, particularly in my country, every minute about some of the implications of algorithms and AI. But one thing was very striking. About 2 weeks ago, that chief security officer at Facebook actually said on Twitter, nobody of substance at the big companies thinks of algorithms as neutral. And too many double negatives here, but everyone is aware of the risks. So That's true at Google, Microsoft, Baidu, Amazon, Facebook, etc. It needs to be true in local and federal governments. It needs to be true in business. It needs to be true in our economic infrastructure, and we need to be thinking about these issues because the truth is you can manipulate data, and you can also just use data in a completely neutral way, what you think of as neutral, and actually perpetuate bias, which as you're building cities is critically important. But here's the good news. So there was an app that was developed for the city of Boston called Street Bump. The idea of the app was, instead of having to stop and send an email to your government about the pothole in front of your house that you kept bumping into, the idea was that you would have an app. There are a lot of apps like this out in the world where you would keep it open as you're driving, and as soon as you went over that bump, it would clock it would geofence you, so know where you are. The accelerometer would know how big a bump it was, and then it would send a message to your local government saying, put this in queue to be fixed. So it's great, right? Except here's the thing. The designers of the app realized pretty soon that there were some biases implicit in their design. One is that you have to have a smartphone, which is probably not a big issue here in Helsinki, but it's a big issue in other places in the world. You have to be able to afford to have a pretty good data plan. You have to probably be driving to work. And you have to have your phone open, maybe not on your dashboard, but maybe on the passenger seat of your car, so you're driving to work by yourself. And so what they discovered was that they were not collecting data about the prevalence of potholes in Boston. They were collecting data on the prevalence of potholes in wealthy neighborhoods in Boston. And so what they did was, and this is really important, they stopped and said, how can we fix this without manipulating the reality? And they said, okay, well, what we'll do is we're going to give this app to garbage truck drivers and to police officers and to postal workers and to bus drivers. And all of a sudden now they had data coming in from all these different areas of the city, and that was a more realistic view of what was going on. So we can learn from the bias that AI incorporates. Here's another example. You've probably heard of predictive policing. It's very controversial, especially where I live in the US. And basically what it does is it looks at areas with historically high areas of crime and tries to predict where police departments should be sending their resources, and it tends to, as I'm sure you would imagine, it tends to reinforce societal biases about crime, because in some areas you can be a young person of color and be pulled over by the police or stopped and frisked and get into the system in a way that doesn't happen if you're a young white person. And so this project was done to kind of flip this idea on its head and show it to people who don't have that lived experience of being, let's say, a person of color in an urban city in the United States. So what they did was they said, okay, we're going to take data on white-collar crime, and we're going to map that. And then we're going to create a profile of the predicted white-collar criminal who looks a little bit like, frankly, all of us, or many of us in this room. And so here, if you don't recognize this, this is Midtown Manhattan, which is a sea of red. And as you go down to Lower Manhattan, which is the financial district, it's also a sea of red. So the idea here is that you can now use these kinds of technologies, and there are many other things being worked on to start to reveal the bias so that we can actually create safer and more just systems. So finally, I want to kind of close out with a couple of things. I'm working on a report right now called The Customer Experience of AI. And in it, I interviewed a number of people from academia, engineers, business people, other thinkers, thought leaders, influential people, and came up with 5 principles that I think should inform any AI project. The first is that it needs to be useful. It needs to do what it says it's going to do. It needs to do it in a nice way, in a way that's delightful and satisfying for the user. or for the person. The next is it needs to be empathetic. And I don't mean by that it needs to understand all your feelings, but it needs to collect data in a respectful way. Here in the European Union, you have the General Data Protection regulations that are coming into effect in May. In the United States, we're still a little behind on that issue. It needs to be designed for inclusivity and diversity. Next, we have trust, and that's about operating transparently and in the interest of not only the institution, but the individual. And then it needs to be fair. So if respect is about the way that we collect data, and trust is about transparency, fairness is about trying to prevent discrimination or discriminatory impacts of the technologies that we develop. And you can imagine what those impacts might be when you start thinking about things like facial recognition and closed-circuit televisions and all those kinds of sensors out in the world. And then finally, it needs to be accountable. There needs to be governance. It needs to have a clear audit trail. We need to understand how it came to the conclusions that it did. So, final thoughts. One of the things that's really striking to me about the world we're living in right now is very much in line with something that Bill Gates said in his book, The Road Ahead, quite a number of years ago, which is that we always overestimate the change that's going to happen in the next 2 years and dramatically underestimate the change that's going to happen in the next 10. So I think this is a really good time to reflect on the fact that we're in a period of massive change, that there's a lot in our control right now. Not everything is written. And I think thinking about the best way to build these systems in a way that is actually productive and constructive and helps build a better city and a better society. Thank you.